Today we're going to look at the introduction to stoichiometry. So we've already learned about dimensional analysis, and we're going to take that same process and apply it now to chemistry. So stoichiometry is simply switching units and converting from one unit to another. You can see in this sample question here, it says a sample of 27.1 grams of calcium oxide is what we started with, and it's asking how many moles do we have of that sample. So as you look at this work down here, hopefully you're recognizing it's pretty similar to dimensional analysis. You're crossing out your units from top to bottom in order to get your final answer. There's two things you need to know and remember to use when you're using stoichiometry. The first one is molar mass. And once again, that's on the periodic table. If we had carbon dioxide as our example, I will look at the atomic mass of carbon dioxide, and the units on that is grams per mole. And I have just one atom of carbon dioxide because there's no subscript there. And then the oxygen, it's right here, and that has 16.00 grams per mole. And there's 2 atoms of oxygen, so I'm going to multiply that by 2. And then I can add that all together. That's going to be 16 times 2, and then we add to that 12.011 equals, and that's going to give us 44.011 grams per mole for our molar mass of carbon dioxide. The other topic we need to be aware of for stoichiometry is mole ratios and how we use the coefficients in balanced equations. So if we make a comparison to building a sandwich, if we have a sandwich that uses 2 pieces of bread, 1 slice of cheese, and 3 slices of meat, we have the ratio of 2 pieces of bread compared to 1 cheese compared to 3 meat. Now if I wanted to make 8 of these sandwiches, I would just multiply each of these by 8. So I would know how many total pieces of bread, cheese, and meat I would use. That same idea is used with a chemical equation. The coefficient before the formula, remember if there's nothing there, it's assumed 1. That's going to be our ratios. So here we have 2 moles of water. That'll make 2 moles of hydrogen compared to 1 mole of oxygen. And so our balance equations are very important, looking at the conservation of matter and mass, but also it'll give us our mole ratio when we're trying to solve stoichiometry problems. So let's just apply that mole ratio concept here so you can see how it's used. If we have this same example, the balance equation of going from water to hydrogen and oxygen, it says how many moles of oxygen can be produced by the decomposition of 5.8 moles of water. So I'm going to be going from moles of water to moles of oxygen. And what I know before I even start is that I have 5.8 moles of water. So I'm going to take that down here and start my solving equation with that. And I'm going to use that dimensional analysis to cross out my units. Now in order to do that, I have to look up here at the coefficients. What's my mole ratio? I have 2 moles of water compared to 1 mole of oxygen. So I'm going to write the moles of water on the bottom, so that way I can cross out my units from what I started with. So let's bring that calculator back over again. So if I now go 5.8 times 1 on the top, and then we divide that by 2, I get my final answer 2.9, and that's going to be 2.9 moles of oxygen. Here's a very similar problem, just using some different numbers. So why don't you go ahead and pause the video and give it a try yourself, and then check back. Once you did your work, see if it matches up to what I have here with your units crossing out and our final answer being 2.1 moles of oxygen. So when we're looking at these calculations and looking at stoichiometry, we're going to be moving in a variety of different ways from units of grams to moles. Sometimes we'll be using atoms or molecules. So depending on which pathway you're going, what you're starting with, and where you're heading, that's going to determine if you're using molar mass or if you're using Avogadro's number. And so this chart here would be very helpful for you to know and just realize that pathway. If we zoom in on the grams and mole part more, I have this other little pathway down here that specifies going from grams to moles, and moles to moles, and moles back to grams of something different. Anytime we're going between grams and moles, you're going to be using the molar mass. And anytime that you're going to be going between moles to moles, down here, on this pathway, you're going to use the molar ratio. So this would also be helpful to know that pathway. Okay, so let's look at a practice problem where we're using moles and mass. Whenever I'm doing a problem, I like to think through the going, know, and solving. Even underlining things in the problem really helps. So I have my balanced equation, and it says what mass of oxygen, so I gotta find that, will be required to react exactly with 44.1 grams of propane. So where I'm going is I'm going from grams of propane, and I'm going to grams, because that's what mass is, of oxygen. So what I know to start with is that I have 44.1 grams of propane. So now I know that this is going to be the start of my solving equation. So I'm going to start writing that in there. And now I got to work on crossing out units. And I'm going to use these different conversion factors in order to figure this out. So if I refresh back and look at this pathway, I'm starting with grams and I'm going to grams over here. So I need to follow this pathway in order to get there. So I need to use a molar mass, then a mole ratio, and then another molar mass. Having the units is super important for grams and also which chemical I'm using. So to start with here, I'm going to calculate the molar mass of propane. In order to do that, I'm going to look on the periodic table, and I would find that hydrogen has 1.008 grams per mole, and that carbon has 12.011 grams per mole. So I'm going to multiply my subscripts and get my final amount there, and that's going to be 44.097 grams of propane per 1 mole of propane. Now I wrote the grams on the bottom because I need to cross out my units of grams here with my units of grams of propane there. So now I am in moles of propane, and I need to go to moles of my oxygen. So I'm going to look up to the equation for my mole ratio. So I have 1 mole of propane and that's going to convert into 5 moles of oxygen. And once again, I wrote it like this, so my units, moles of propane, would cancel out with moles of propane. And then the last thing I need to do is I need to get from moles of oxygen into grams of oxygen. So if I look at the periodic table, the molecular mass or the molar mass of oxygen is 32.0 grams because I got 2 oxygen atoms per 1 mole of oxygen. So I cross those units out, and I'm left with grams of oxygen. Now that's what the question was asking for. That's what I wanted to go to. So now I can figure out what that equals. So if I pull the calculator back over here, and I'm going to have to extend the page here a little bit. There's 2 different ways you could do this. You can multiply across the whole top and then I would push equals or use parentheses to divide by everything on the bottom. Some people will also multiply everything that's on the top times a 1 times a 5 times 32, and they'll actually write that out. So they'll write 7,056. And then they'll do that same thing on the bottom. So they'll go 44.097 times 1 times 1, so we would know that's the same thing. So now they get this, and then they can plug these two numbers into the calculator. So there's different ways to do it. As long as you're getting the right answer in the end, it doesn't matter how you plug it into your calculator. So my final answer here is 160, and that's going to be grams of oxygen, because that's the only units that I'm left with. So crossing out my units as I went using molar mass and molar ratio, I was able to go from grams of propane to grams of oxygen. Now I have another example here for you. So go ahead and pause the video and try to work this one out on your own and see if you can do the same thing. If you try this one out, you can check your work here and hopefully you got the same answer. So hopefully here you got a good background of what the stoichiometry is about. Keep on doing different practice problems and applying those pathways and the conversion factors, and you'll soon become a pro at these. Have a great rest of your day.